So I have 3 pickup items, a nest, a food pickup, and a gold pickup. We're looking at the food pickup right here. I used to have individual scripts for all of them, and today I refactored into having just pickup script, which you can see right here. Let me go ahead and show you what we're looking at though real quick. Let me make sure it looks good. Okay, so I'll show you the simplest one first. These are the gold coins, and you saw how I picked them up and they added. Now here's the most complex one. This is a, well, let me do this real quick. I have to clear out my energy for it to let me pick up the eggs. So whenever we hit these eggs, these chickens, the nests spawn and fill up with eggs. When they don't have three eggs in them, they will not attract to us, but once they are filled up, they will attract. And there's a counter over there that you can see in the left. It's counter 18, and we can get that up to 25 before it won't let us pick up anymore, and then the eggs will start to say no, can't collect them. Now over here at the campfire, we can spawn cooked eggs, which this is a specific food item, and we can get 5 of these. So now we have max energy. I'll show you. This is just debugging. Now I'll show you. This is also a food item. It's a meat. Well, it won't let us pick it up because. So let me go ahead and use this. Alright, so now we should be able to pick it up, and it'll count it over there for us. And these are all the same object. Oh, what the hell? There we go. I couldn't find the button. And they're all the same. They're a food item, and that'll count them up, and it'll stop us when we have the max quantity or when we have too much energy. So basically, the point of showing you that is like I was saying, I used to have 3 different scripts for all of that with a lot of duplicated code. And the reason that it was duplicated code is because while there was some similarities, a lot of the things are drastically different. Like, you know, the nests are really different from everything else, like extremely different. The food is really different in the sense that there's like 50 some odd types of food. But it was starting to get unmaintainable, so I did some refactoring that I'm going to show you. This is a Defold project, as you probably saw. So what this means right here is this is basically this is like a metatable, it's basically a way to sort of imitate the behavior that you get from classing and subclassing and overriding methods on classes, and you can use duck typing to do that. So this is our base class, and here we're setting the metatable. You can read about how metatables work if you want. It's like I just learned about it like this week, so yeah. And so here basically we're saying that this is how we instantiate a new collectible item, and basically you copy all of the key values from the thing onto the thing. So yeah, anyway, the point is that, so right here we're gonna call self init. The reason I do that is because later in the more complicated one I want to override init, but on the simplest one it's just collected. It's not yet collected, false. Now the same thing is true here. Set sprite animation. I could have put this up in the init, but the reason I put it here is because I want to be able to override this without overriding other things. And basically what this does is, for the simplest one, it just gets the default animation off the sprite, which is, right there. And so then here we're saying update sprite animation. This is similar to set it, but this is for the update. And the reason there's nothing there is because the most basic behavior is that the pickup item doesn't change its animation sprite ever, so it doesn't really need this. And if this gets called, which it will get called, it doesn't do anything. And then here's where we spawn, and we call this set sprite animation. We do that here, and then we set and we play it. And the reason we play it, even though it's already going to be playing because it's set on the game object, is because if we want to override set sprite animation, we want it to just update it automatically and play the correct one instead of having to override both of these. And so here we're just putting an animation on the scale to make it kind of like appear from nothing, and then we're setting basically if it has a lifetime property right here, then it will despawn it, which is right here, the opposite. It will scale it back out. Now here we have is attractable, and we just set that to true because the default behavior is that everything should be attractable. And this is where we do the attract to player by proximity. So here we say if not the is collectible and not is attractable, then just leave. That way when this gets run, if the item isn't collectible and it's not attractable, then just don't do it. Same thing here is if the collected items already been collected, then do the same thing. And basically what we do here is just calculate a distance, and then we move the item towards the player if the attraction is close enough. And then here's the collect method, and here we'll basically do a if it's not collectible, we'll interrupt the collection. You'll see that in a second. Here's where we mark it as collected so that it is marked as collected. And we kind of have two properties here. I think we could have gotten away with just this one, but that's how it is. And then we disable the collision object because we're going to animate it and we don't want it to interact with anything else. And then it is collectible. I probably could have had that up there so it would have been cleaner, but its default is just true as well. Now the interrupt collection is basically just, it's that thing where it shakes back and forth. It's just to tell you no. It's basically something to do if it's not going to collect and it's not collectible, then do this instead of what it would otherwise do. Now if it's going to animate the collection, we've got basically a timer delay here where we calculate the arc on 2 axes, and then we do a callback on one of the axes because we only want to do the callback one time. And so the callback here is to provision the item and delete the object. Now provision the item, the default behavior for that is because there is no item specified, so there's nothing to do. So here we're going to do the gold. So this is how we subclass, basically the same way that we defined the original classes. You just do collectible equals that, and then set the index to this. And basically all we're doing is we're just saying that when you provision the item, increment the player's money. It's the simplest one, and that's all it needs. Now the next one is the food, which is slightly more complicated, not much more complicated. So here, because there's multiple different types of sprite, which were specified here, variety enum. Let me see if I can get down there really quickly. Yeah, so it basically, I'm not going to show it to you, but there's like a food module with a lookup table that can get the enum, and then it knows what the ID is for the thing. So we're basically setting it based on that enum. You have to use an enum to pass property to a default object. Anyway, we don't have to, but you can't use a string. So, and then basically when we provision the item, we're basically using the food module to increment. It handles all the adding the thing to the GUI and all that kind of stuff. And then the is collectible part is basically we don't want to collect a food item where we have the max that you're able to carry. That's basically what that does. So it'll make it to where it's not collectible. And then that's really it. Otherwise, it's just all this default behavior. Now here's the really, I wouldn't have done this pattern if not for this next one being super different. And yeah, and it just being really complicated. So the nest is different than any of the other ones. It needs a completely new init. So here we start with calling that would be similar to how you do, like, the base class super init and a normal object-oriented languages. And then here, I don't think I use this anymore. I think I could get rid of this, but basically here we're tracking the egg count, the max eggs possible. These are the nest colors. We pick a random nest color, and then we say the current animation is nothing. This is important because when we set the sprite animation, well, you'll see why it's important. So we're setting the sprite animation, and then we don't have to override anything else, the spawn, because it knows to set it for us, like in the spawn method. And then here we're just pushing it to the bottom so that the player can walk over it. Here the is collectible it's not collectible if it's, because when the nest first spawns, it doesn't have any eggs. We don't want the player to collect it when there's no eggs in it, so we stop that. Here we're basically looking at, we just hard code in egg raw because the nest's always going to have raw eggs, and then we just look in our thing and see if it's over the max. And then also we have a max energy value it's another thing that goes into the food system that stops you from collecting more food. And then so the update sprite animation, this is because every time a chicken is hit, it spawns an egg from the chicken to the nest, and it has to update the sprite of the nest to reflect the added egg. So here, that's what has to happen, and that's why we're calculating from the egg count what that new animation should be, and then we're checking if it's the current one, if it's a new one, and then we'll set it, and then we'll set the current animation. And here, this is the reason we have is attractable, is because we want you to be able to collect a nest that has 1 or 2 eggs in it, but we don't want that nest to come flying towards the player when it's not filled. Otherwise, the player would have a hard time filling a nest up. So that's why we stop that there. It only attracts if the egg count is the max eggs. And then so here we are animating the collection instead of, you'll notice that same thing from before, the timer delay, only this time we are iterating over the number of eggs that are in it, and for each one we're spawning an egg. Basically it's just there superficially to show the animation, and then we're calculating the arc the same as we do with the other one, and then here we provision the item, delete the egg, and then if the egg count is the total egg counts, then we despawn the nest. And when we provision the item, like in a normal item, we would provision 1 item. Here we're provisioning 3 items, so it'll get or 2 or 3 or 1 depending. And then so here is where the default lifecycle functions begin. And so here it's basically saying if the type didn't get set, then just delete the object and return, because you can't spawn an object that you didn't specify. And then so here we're basically passing the properties to the script to the class, or if that's what you want to call it, to the class. And then here we're looking at if this hash would be passed to pickup type, and if so, it would spawn the collectible gold. And here the props are being passed in. They're up here. Basically they're the same things that are up here at the top right here. Yeah, so it'll just pick which one, and then it will item spawn. So now, as long as every one of these has a spawn, it will use the correct method. If it needs the base method, it'll use that one. If it is defined on the nest, it'll use the nest one. If it's not, it'll use the base one. And then here we're storing the item to self.item so we can access it in the rest of the lifecycle functions. It's important to note that the self from up here is not the same self that's down here. They're different instances. But here basically in the update we're just doing the attract player by proximity, and then the message is here. Basically this is handling the collision, and then whenever the collision happens and it's an entity to the player, then we do collect. And then this is here for the eggs. It's basically just because something has to tell the eggs to update, and that's what that is right there. And basically it makes it a lot easier to like have all of this. It basically makes it easier so that I can modularly, extend this and just reuse code as needed and change code as needed. And it's a pretty cool pattern that I learned about. You could just read about Lua metatables as classes. And if there's any problems with the way I've done this that you've noticed, feel free to point them out, because I did just learn about this. This week, and so it seems to work, but I'm not sure if it's going to have problems that I will run into later.